Hello. Hmm. I had a nice, relaxing weekend. Hell yeah. I watched this animated movie, Chinese animated movie called The Legend of Hei. Hei. It's very good. I do recommend it. It's like um, spirits and humans and powerful dudes. So military. There's two movies. It's cool. So what I want to do is basically pick up where I left off on Friday, which is oh boy, work, work. No, my code. Uh, so I opened an issue. Oh, this issue. There's two new issues. Ugh. Uh, with body position and mesh in B-Hub ISO, the function returns the wrong one. Oh my gosh. The wrong one. No. So I actually don't know if that's true. Or if it's like the Fev crawler. Well, no, didn't I look at it? Let's see. Wow. No. Mm-hmm. Okay. So we don't need any of this. Um, yes. So it's gonna be this. Um, oops. Weird champ. Okay, so this is bug MD 909, whatever. And then we're loading the map ISO. Strafe, tools. Streamable map. Yeah, I think I got the architecture that I want. You know what? I don't really want to listen to this. Let's go to my trick music that I thought was real music, but is actually AI music, but I still like it. Can you believe it? Oh, I'm peeking up over the. Hi. Second camera. Apparently, this is AI music, at least in part. I was tricked. It's really nice. Just because it's AI doesn't mean I don't like it. I certainly don't like being tricked. Okay, so we don't need physics data. We do need physics data. We need a specific mesh. Physics models. Mm-hmm. We'll see if I'm even able to do that. Um, so love it. Oh, right. It's gonna be just like physics data dot models, and it's gonna be like, oh, it's private. It's private. Whatever. I wonder if I can. Why don't I make a little function called mesh? Is it U32? Oh, I'm dummy. What's the point, man? Okay, Jesus Christ. Okay. What do you want? Oh my God. Wait. My contact. Okay. Okay, so that will get me all the way there. Mesh. 1020. Fantastic. Hmm. Okay, how do I expose this? Hmm. So basically, I just only have to do this. And that's it. So we have contains point. All right, I'll just do it. Let's just make a function. Closest point. Self point. And we return a fev, I guess. That includes the lifetime. But really it doesn't matter. So legitimately we just do this. Lifetime may not live long enough. That's actually not correct. Oh, it does say MM. Alright, it probably doesn't matter, right? Okay, buddy. Self. Well, you know, so. I don't know. Begun. Self. Okay, closest point. Test. What on the loud side? Ski. Uh, Can I not construct a Minkowski from outside? All right. Oh wow. Okay. Um, I'll just blast it into the function wherever the function is. We don't care. Um, real? You good? No. This is in model physics, Fav. Yes, it is. Okay, we have a function. And then the test goes like closest point. And then the point is right here. PV3, Vec3, F32, bow, bow, unwrap. Okay, and then this is nothing. Fev equals. That's it. Okay. Branch. It should be on the master branch here. Yeah. Okay, and then debug. Number 26. Let's go. What are you doing? Goober. Oh, is it? Wait, what? Oh, it's here. Okay. Whatever. Okay, bug 26 is real. Yeah, that type of situation. So I need debug stuff. Yes, I need the Lua stuff. Give me the Lua stuff. Ooh. Give me like here to here. All right, what do you got? We want both. Yeah, nice. Okay. Okay, so this one we don't want that. This one we want that. So there's Fev inside and then Fev inside inner. Bow. And then there's no such thing as okay. We good. What? Don't. Okay. No. We good? Difference of details. Yeah, that's right. That's right. Yeah. Okay. Come back. Okay. Continue. Crap. Loop. On the loop. Just get the loop, man. I want both. Hey, yeah. Okay. Run the track. Debug it for me while I'm gone, okay? Did you debug it? I have to do everything myself. What am I, the main character of Skyrim? No. Alright, so what happens in Lua? Reduce 1, reduce 2, reduce 3. And then what happens in Rust? Reduce 1, reduce 2, reduce 3, reduce 4. So they are. Oh, they're okay. So they don't disagree about whether the closest point is there or not because the objects are intersecting. But clearly, they don't do the same thing. Point O. Next point. This is not the same. So this one is the same as this, nearly. It is off by 1, less than 1, but it's not very sensitive to changes like that. It can affect it, but it's not likely. Ugh. False, 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 true, true. How did one of them give false, false, and the other one gave true, true? Is it like really close? I bet it is, isn't it? Okay. Okay, the algorithm down here. Algorithm. False, false. So in Delu, less than or equal to 0. Okay, it's not that close, right? Cond. Oh, do the cons matter? On exact, yes they do. Okay, so next pause minus last pause. So, oh, next pause minus last pause. Am I right? So that's gonna be like negative 40 something and 0 positive 2. Negative 40, 0 positive 2. That is just like a freaking perpendicular vector. So we're printing the cond. Oh, debt is 0. Let's change this to dot, I guess. D. Amazing. Oh, we already have D. Amazing. Okay. Did I do it? No, I didn't do it. D. Well, we can call it D1 actually. And then, yep, and then D1 is positive. Try that on for size. Should be like 0. Ugh. D1. All right, let's try debugums. Okay, so it's a very small number. And it's trying to... Oh. So this one, just like yeet. It's just like get out of there. We gotta get out. The number's too small. We gotta get out. This one is like we can go further, smaller, smaller, and then it finally succeeds. Vert. Wait, vert. Hey yo, I don't think that's right. Oh wait, no, that's totally right. What is the matrix? Let's print the matrix. Print it. Model mesh transformed mesh. Transform equals bow. Model, hello? Model mesh dot transform. Alright, I'm just gonna go in and break it because I need to. Whatever, just print the whole thing. Actually, we can grab the matrix. Oh, vertex dot matrix 3. Yeah, jeez, okay. So we'll be able to see the little guys. Okay, so this is a matrix. So what are we looking at? So our x vector is pointing in positive z. Our y vector is pointing in negative y. And then our z vector is pointing in positive x, and that all makes sense. Okay, so this is positive x. Okay, so x y z, and it's like this. So x is slightly negative, or yeah, the x direction is slightly in the negative x direction, which that's what a thing to say. The y direction is slightly in the positive x direction, and then the z direction is slightly in the positive this is the positive x direction. So it's like, yeah, so it's gonna be what? So that's like huh. Minus huh. And then z is sticking this way. Throwing x a little bit negative, That a little bit positive. But that goes up. Okay, so it's just a messed up matrix. So it should be no effect, no effect. This goes because this goes up. So it'll make the vertices go up for positive z. It's not possible to make a non-convex mesh by making a skew matrix, right? Or any matrix. Yeah, you can't skew transform a convex solid into a non-convex solid. Okay. So like if this is sticking up slightly, so it's this axis is slightly this way and slightly up. Hello. Which like that puts this vertex higher than all the rest. So if we're like trying to find the closest point to something up here, it's this vertex. But we're not. We're like over here or something. I think. Let's go run the track. ISO. Do I have H? H me. H. No, I don't have H. Okay. I need H. The... What? Right. Yeah. Right. Let's bop this as well. Build it. Okay, and then I should be able to go back to the scene of the crime and recreate the situation, and none will be the wiser. This is faster. All right. This is the criminal right here. This part. If I go right here, and I press H. So if we look at the hitbox here, the hitbox is squarely within the border. of this object here, squarely within the border. But it thinks that the closest point is on the edge. But the closest point to this is somewhere on that surface. So this is totally wrong. And that's what I'm trying to figure out. But it looked, it looks like it's actually returning the corner. Let's see the diff here. So this is our H. If we swap, pop it and swap it. This H is 8358. 76. Let's give it a go. It might just be different and more easy to debug. Go. Is it different? So this is reduce 3 con true. That looks exactly the same. And this is reduce 4 exact. Also looks the same. And this is still giving vert. So if you recall what I just did where I hovered above that criminal platform and I just pressed H and then it displayed the edge, that means that in the game it was returning the edge. It was like, here's the closest point, it's on the edge. But the code that I had written only called this function. So it shoulda. Let me go back and like verify it again. So I'm gonna just blast this out. Say like, hi, hello, Fev. And it'll just like spam, but whatever. We don't care. Okay, we go back to the map. Go to the scene of the crime. So I go somewhere around here. H. No, not quite. H. So see what this is spamming in the console here? It says edge vert. But our our other test is calling vert or returning vert. So I am not actually reproducing the issue correctly. But it still appears to be a bug. Maybe the same bug, maybe a different bug. I would very much like it to print the same. You get the same result. Wait. Wait. This one says simplex 3, vert. That's a plane. It's returned a plane. This looks like exactly correct. I have completely failed to reproduce the failure. What? What? How am I gonna figure this out? So now the problem has changed from figuring out why it's broken to figuring out why I can't tell that it's broken. I have to abstract a step. Figure out why I can't recreate the broken case. This looks exactly correct. It's returning a plane, which is kind of like a face. Wait a second. What's the true output? So it exits the algorithm and it says I'm done. But that's not the end of the story. So right here it exited, but then it has to do another algorithm to actually determine the canonical location on the mesh, because it's just a set of 3 vertices which may or may not actually form a face. So it has to like scan around and like figure out if it's like part of a face or whatnot. So it could be wrong in here, which is my code, and I should understand it. Yeah. Could it be a thin skin bug? I don't know. We print after. Fev. Who are you? What is this? Fev. Oh, I'm in the other. No. Oh. No. So we. It's right here. So I have the Fev. Print it out. Fev. So let's see what the actual Fev is. So it says it's a simplex 3, which is a triangle. Ah, okay. Okay, okay. Okay, so it's my code that's messing it up. Oh. So, I recently did a comment that removed some print crap. Oh god. Implement. Where's? Yeah. Give me this. Revert that. Yeah. Give me that. Yeah. Does that go here? Yes, it does. Okay, so I think it's running an edge case of the edge case, and it's wrong. I can't believe it's not a face. Yep. So I was right to worry. Wow. I don't know why this is happening. We'll start looking at the code then. Okay, so we're crawling. So what does it do? Vert edge face. So what it really is saying here is that the closest point is on this simplex. Which is a triangle. And it could be like on the edge. But probably not. Realistically, it should always exit through this case. But it appears to be exiting here through this case. Um, why don't I print this? And then just see what it prints. My thick plane might not be thick enough. Should be thick enough. One, two, three, four, five, six, 7, 8, 9, 10. Oh. Ooh. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4. Oh. Yeah, no, that's definitely bigger by 2 orders of magnitude. So none of these numbers are close. So maybe that's not it. Uh, so which ones are killing it? Probably both. Oh, not. Oh no, yeah, both are killing it. So one of the faces is behind. My intuition is telling me that that's always true for one of two. Um, 5 days ago. Let me at least write down my progress. So what does that mean? So what is the algorithm even doing in the first place? Crawl to closest fev. This function drops a vertex down to an edge or a face if the path from infinity did not cross any edge vertex boundaries, but the point is supposed to have already crossed a boundary down from a vertex. Yeah, that's not correct. Basically, it needs to not do that. Hmm. Hmm. Did I write this code? Starting with a vertex. Yeah. 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 So, um, the idea is that the minimum difference algorithm returns a set of vertices that may or may not actually correspond to a canonical face on the Minkowski mesh, which we can pretend is a normal mesh. So if this is the mesh, you can imagine that it's made up of polygons, and each little square is 2 polygons. And then the minimum difference algorithm just goes like, oh, the closest point, yeah, it's on this face. And it's like this vertex to this vertex to this vertex. And that forms a triangle. So the closest point is somewhere on there. But that's not a canonical face on the mesh. The mesh has only these little tiny polygons that make up this face. And like, yeah, it's a convex mesh, but like there's a lot of little polygons in between. There's a lot more detail than the minimum difference algorithm returned. So what we have to do is like work backwards and like look, crawl across the surface of the mesh, hopping between vertices until we find the actual polygon that which contains the closest point. And that should never fail. It should never fail. Because of the way the minimum difference algorithm works. It would return a line if it was supposed to be a line. And that does actually go through this algorithm, but it's still capable of returning a vertex. EV, edge or vertex. And it should not be. I'm not sure. I think the bug is right here. Or right here. Because I kind of just hastily put this together. But it's not so simple this time because I don't have any correct code to compare to. Let's fix the comments. This function hops along flush faces until it finds the face which contains the closest point. 2 point. Edges. Parallel. Yeah. That's all it's really supposed to do. Crawl. ensure edge contains closest point and directed edge is coplanar to simplex. What the hell? Directed edge is coplanar. Oh, okay. Constraint contains. So this is the coplanar test. Edge contains closest point. Yes. Okay. So it can't be. It can't. The point can't be over here. It can't be over here. It has to be just right in between. In between those two. Those two tests. The idea behind closest fev is to like start with vertices, and if you just like go and like look at all the vertices, the closest one will necessarily be part of the face that contains the closest point. So like it starts out looking at vertex connectivity up here, next transition vert. So vert edges, edge verts, vert. So for every vertex, for the input vertex, it looks at the edges. So like imagine we're like here. There's how many? 1, 2, 3, 4, 5, 6. There's 6 edges connected to that vertex, and it'll test all of those vertices that are on the opposite sides of the edges. Why don't I draw it? This is confusing. Can I like never see this ever again? All right. It's a square. Okay, that's too much. I'm a dummy. It's gotta be. That's kind of nice. Should have done that from the beginning. Okay, so we have this crazy set of polygons that make up a Rubik's Cube. So, what? The minimum difference algorithm is going to return a set of vertices that form a simplex, aka a triangle when it's 3 vertices. it's going to look like that. Greedy meshing. No, we don't want it to anything like that. Because it's the Minkowski sum of two meshes. We don't actually have a mesh that looks like this, but the algorithm needs to work on this class of meshes because the Minkowski sum of two meshes will generate something that does have flush faces. It won't have this many flush faces, but it'll have like up to 2 on one face. What are we talking about? It's very complicated. I'm trying. So I've narrowed down the location of a bug. When is it not complicated? Yeah, I've narrowed down the location of the bug to like here. So, okay, well let's go back and look at it. I'll take you to the beginning, to the scene of the crime. All right, so what does this do? H. So here's my cool, interesting visualization thing that like shows the current closest point to that moving test point. Well, moving test mesh. So it takes the Minkowski sum of the hitbox mesh and whatever I put my cursor on, and then finds the closest point between those two objects. Did you shave recently? Yes, moments ago. And that's great. It finds the closest point. Oh God, it's spamming. Oh my God, bro. It's fine. So if I just kind of like chill here, right? H. Right? That's the closest point. If I chill right here, H. That's the closest point. And it can just do it. But there's a problem. H. Uh-oh. It's not correct in this case. So it's saying, oh yeah, the closest point is on that edge. No, it should be on the face. It is clearly closest to the face, not the edge. So I'm trying to figure out why that's wrong. And my algorithm, Trey's algorithm is returning a simplex 3 as the result. So it's a list of 3 vertices, also known as a triangle. That's a plane, not an edge. So that makes it go to this case right here, simplex 3. And then it runs this code. And then instead of coming out as a face, it comes out as an edge. So it returned a list of 3 vertices, and the closest point is like here or something, and I was like, nah, this is the closest point, when it should be returning this. This is the answer. It should return that, but it returns this or something like that. And that's the bug. So I was gonna go over how the algorithm works. So basically, it's we start out with three vertices. So this one, And we're trying to find this triangle just based on the return value of the minimum difference algorithm. So the first thing it does is it finds which of the vertices is closest. So for each one, it does distance squared and then finds the minimum one. Easy. So then these ones go away and we just work with that one. Okay, so we got vertex here and we're trying to find this closest point. So the next step is it finds the edges connected to this vertex. So that edge, and it repeatedly tests if the vertex at the opposite end of the edge is closer. So it's gonna test this against there, and they are closer. So it'll get rid of this one and choose the closest one, and we don't really know which one that is, but let's say it's this one. So it's like ooh, and then so yeah, that's the closest one. And now when it repeats it and it tries it again, it tests. Oh, one more. It tests all those vertices. It's like, no, we have the best one. Yes. So then the part of the algorithm is complete. So that is this crawl boundaries, kind of. So crawl boundaries. Transition vert. So transition vert goes vert edges, edge verts. And then it grabs the one that's the opposite parity, which is the one on the far side. Select opposite vertex. And then it grabs the difference between the test point and the test point. It's the distance squared. Is the distance squared less than the current best distance squared? And it also must be in the plane, because like you can have vertices that are not in the original plane. So what is the original plane? The original plane is this thing. So this thing forms a plane, and if the vertices go out of the plane, we can't count them because they're not like in the solution. Yeah. Okay. So that's this. So it does this loop where it hops along the vertices until it finds the closest vertex. And it's for sure the closest vertex. But at the same time, it tests the edges. Test if this edge is closer. Do we want to be doing that? So like, yeah, so looky. So evidently it's also testing the edges at the same time. And it'll test the distance to the edges. So it's like, and like that one again. And so this edge is the point. The closest point to that edge is over here, and that's outside the edge bounds, so it's immediately gone away. But all of the other ones, it is within the edge bounds, so it'll test the distances and it'll be like, this one is the closest, and so then we'll end up on. Why don't I draw this point first? We'll end up on this edge, and then that's the output of this is an edge or a vertex if the vertex was closer than the edge. And then that's the output of crawl boundaries. So we started here. We tested the 3 vertices, found which one was the closest. And then we crawled across the boundaries, hopping and testing vertices and edges. And it found either the closest vertex or closest edge. And in this case, on our thing here, it found the closest edge. So it's going to output right here. And then next, it tests the edge faces. So that's going to be this face and this face. And it's going to make sure that the point is on the correct side of the returned known closest edge boundary according to the face normals. So what the hell? So we've got the edge direction here of our good amazing edge. The good amazing edge direction, amazing. That's an arrow. So that's the edge N, I guess. Normal. That's not a normal. It's the edge direction. Oops. And then for each of the edge faces, which is this face and this face, it finds the face normal so this is now going into 3D. If the test point is behind the face is invalid. So all the faces point out of the mesh, and if your point is inside, bad. No. So reject. Right. So you can think of it like this. Imagine the closest edge is like here on our diagram. So that would be like this edge right here. So there's a face here and a face here, and it would be testing both of those in this loop. And then this point is behind the face over here. It's not, the test point isn't hovering above the face on the side over here. It's behind it. That's invalid. So that's what this thing is. It's quickly getting rid of invalid test faces. And then now we construct the edge face boundary ND values. So we're taking the face and the edge and constructing a set of 4 numbers that describes a face, a plane. Right, it's like ax plus by plus cz plus d equals 0. That's like the d value. Wow. Yar. So what is that? We're going into 3D again. So between each of the triangles, there's like planes coming up and going to infinity, and it forms a thin column, like a shaft of air above the triangle, a little strip. And what we've done is we've constructed this plane here that's between these two test faces of this loop. So we have a plane diagonally between the test faces there, and we're testing whether it's on the right side of that plane, the correct side. Is this wrong? No, because you negate. Well, couldn't I negate the dot here and that would be faster? Yar. Oh, that it does that. Okay. Delta pause. What is delta pause? Test point minus the average of the two edge vertices. So that is this vertex and this vertex, and it just does the average just to be like fair. And then if the dot product of this vector is not positive, then it must be on that side of the edge. So we started with this edge, and all we want to determine is one of these two faces closer than this edge. And in this case, the answer is yes. It should be on one side or the other. And return the face. So I just walked through the entire algorithm, and I didn't see any problems. But like the math could be wrong somewhere. So one of the faces was behind, and one of the boundaries was positive. Edge in. Oh. Wait a second. Edges. This is. Where's the edge parity? So the edge normal will flip. I'm going to flip. The edge normal will flip randomly and destroy this dot product, and it's random whether it's correct or not. Oh. No. That's not true. Edge faces is oriented. Yeah, so it's always going to choose edge refs. So the undirected edge is oriented. When it asks for edge faces, it's always the left face, then the right face, according to the edge direction. So this is left, this is right. Or if the edge is facing the other direction, then this is left, this is right. Presumably, they're constructed correctly. Otherwise, the rest of the physics wouldn't work. I'm just getting excited there. I thought I found a bug. So this is random, but then this has the same parity. It's not random, but like this could face either way between the two edge vertices, but then this faces the same way. Oh my god. Cross product. Can't this is a triple product. Can't you like just like do it in any order? Cause like if I crossed these and then dotted that would be less work. Good. Well, damn. All right, what if it's not negative? So now it returns a face. Is it a correct face? Let's run the track. Yeah. All right. I bet you I fall to the ground immediately. It's just gonna, the whole thing blows up. And like everything is now non-collide because the physics is wrong. But I don't know that for sure. Oh! Was that just like wrong? Could be. It's like some random crap. Oh my god. I never go this slow. Oh, I went through that. Yeah. Okay, so I'm. I look like it is looking like I'm falling through things more than usual. Oh, I can't make that. It is what it look like. I need to print. Give me that. What? 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 Where is it? What? What? Oh, wait, I have to cherry pick it, not. Okay, I'm dummy. Okay. All right, these unhelpful prints are actually helpful. Yeah, cuz like I can see that I'm falling through stuff, I kind of expect it to be like mega wrong, but like it's not. Oh. Oh. Okay, you know what? Be bigger. All right, what if I go here? Okay, so that still happens. If I always come at it from the same angle. But if I come at it from this angle. Oh. I don't know what is what bug. Seems to me that it's potentially giving out the right answer and then throwing it away by using this fallible algorithm. Should I test faces only? This is my favorite part of this AI music. This song and the next one are so good. Be nice to visualize it and like display it like testing the vertices, testing the edges, testing the faces during this loop, and then the final test. I can make it async. That would work really well, actually. Like, you could tell it's AI music because why does the guitar turn into vocals? How is AI music good? It also has like a soft sound where the instruments are like soft. Like there's no sharp waveforms. It doesn't sound crisp. I'm kind of making stuff up, but that's what I've noticed. I don't know what to do. I think this doesn't matter. It might just be destroying correct faces in some case that I can't think of. Oh, did I invert the test? This is still inverted. Yeah, okay. Let's invert it. Imagine this just works and I can just ignore it for the rest of my life. Another goated song coming up. Ah! Is this a song? I don't think it is. Damn. Okay, so far so good. Ah! Nice. Speedy. Ah! I don't know how to do this part fast yet. I'm just playing the map for fun. I could test faster, but you know what's fun? All right. This is the test spot. Okay, it still happens. And it is the same bug. You can see under me it says, I can't believe it's not a face. Didn't fix it. Hmm. This song is my favorite. Why don't I work on something else? I'm gonna put away my coffee. Ooh. Okay, why does it do that? Hmm. Is it the map? I so I'm gonna switch it up. Hmm. This music is so stuck in my head. I love it. What? Wait. I think I'm falling through the ground. let me try something. Oh. Let's try that. Fixed. Well, that was an annoying bug. Um. Uh. Fix reset bug. Is that a issue? Nice. Uh. Okay, good, good, good. That is very nice to fix. I did something today. Where am I going? That doesn't seem like a very good route. Ugh. Cool. I bet this map would be fun to route. That is too far. What time is it? You got 40 minutes. So what else can I work on? I guess I've got a bunch of bugs open there. Right, I can't even play my own game without lagging the stream. It's really annoying. What the hell happened? So one thing to note about the Strafe client physics is that if you do a bunch of stuff before you start your run, all of that has to be included in the replay. So I would need to make a little thing that limits how expensive it is to calculate the initial state of your run when you leave the start zone. So the moment you leave the start zone can't be after an hour of like doing figure eights in the start zone. Whereas in Roblox it doesn't matter. But in this game, it needs to recreate the entire sequence of events that happen during the run to recreate the internal physics state. Rather than just like playing back a set of positions, it's actually re-simulating the entire run on replays. So like, this is re-simulating the physics from the last time that I reset. So even though I'm in the start zone, it's not like the beginning of the replay, even though it's the beginning of the run. So probably what I'll end up doing is auto resetting you if you enter the start zone with a bad state. So I guess I could literally just run it on your computer. I'll make like a time limit. You can't spend more than 1 minute or something outside the start zone before you start your run. So if you go like this, and then you start, whatever, just include it in the bot. But if you do this for an hour, and then you go like this, it'll reset you automatically. Which is a little bit annoying, but I guess actually the important thing is like the number of ticks it has to process. So if you're just sitting here and doing nothing, and it can condense that into less than like, I don't know, 100,000 ticks. 60,000 ticks. Then I think that's good. I wonder what the speed is. Why did I go wide? The tick rate. So I think I saw it can go up to 40,000 ticks per second, which is pretty good. It used to be way higher, like 100,000. But it was also way simpler. I didn't have the like integer physics. God, I suck. Jeez. Yeah, let's just add like 8 extra jumps for no reason. And slow down. I'm just like, I don't actually know what I need to know about the algorithm that I was debugging today. Like, what I actually need to know is like specifically which vertices is the specifically which vertices is the minimum difference algorithm returning. I need to like visualize that, see if it's correct, and then also see it on the hitbox mesh, maybe as well. Go! So bad. There's just so much like distance waist curving. It's really fun playing this. Fast. Can't even get out of the start area. Yeah. Go narrow, go wide, go long. That's the alternative. Up. Oh. Nearly made it out of the starting area. Okay, that's a little bit nicer to do. Less like compressed feeling. Oh, I totally thought that's totally doable. It's kind of a stretch, but that's the whole point, right? Routing. Yeah. So there's no clip and TAS. Both of those would be interesting. Ooh. Nice. Ah! Oh, come on. Come on, man. Oof. Uh. Woo. Nope. Damn. Uh. This is hard to skip. Man, I worked so hard to make this map work properly. Like, these meshes here have different physics than they have visuals. The visuals are unions of all things. And unions just didn't work the first... at some point in the past, unions didn't work. And I made a actual straight up decoder to make them work. Come on, come on. Yeah. Ooh. Okay, don't die, don't die. Ooh. Up we go. Come on. One try. Up we go. Slow and steady. Across the gap. Don't die. Okay, we made it. Checkpoint. Woo. Woo. Damn. I wonder what my best time is on this map. Surely I did a run of it. I think so. Dun, dun, dun. I think that this music has to be like AI enhanced, not enhanced, but AI supported. So like the music artist did something in the production of the music rather than like it just like prompt and then the song spat out. Because like I refuse to believe that AI can make something this good. Just like straight up. Whoa, I read the map. 420, 516. and then this many microseconds, and this many nanoseconds. So good. Oof. Hello? Well, I fixed that bug. Simultaneity. Excuse me. Well, it's I have at least found source of the bug. But yeah, a visualizer is what I need. Once again, how sad. Visualizers, it takes so much effort to make. But I have like 70% of the components now. I wonder if I can mainline all of the parts without it being stupid. Cause like let's just see. So fcrawler viz is based on this comment. What kind of stuff? So engine graphics adds physics dependencies. Yeah, you don't want that. And you don't want that. That's dumb. So graphics, physics model mesh. Yeah. I couldn't change the color. It's funny. I tried to change it to blue and green, but it's all just red. Haha. Is it overwriting it? I don't know. It doesn't matter. Graphics. Physics. Looks annoying. Um, where's the rewrite? Lol. It's not the right way. Can I even rebase this? Might actually work. Easy. Love this. This is awesome. Oh right, I actually can't. Hmm. It's too difficult to index. I mean, oh yeah, I'm streaming. Just reading through the public API chat. 5 men begging for features that he could add himself. Please do all the work for me. So this is like nice. Vert, edge face. But unrealistic. Yeah, so we still, yeah, fev. Um, uh, okay, why don't I go in here and mess things up? So I'm gonna make another layer to this trait here. Um, mesh. I don't know. Um, type situation, and then there's no such thing. Is it ID? It is, but like whatever. Oi. Oh, is it trolling? Oh, it's trolling. Throwing? Minkowski mesh? Oh, am I dummy? Okay, so this then goes like here. Ample mesh for Minkowski M. Yeah. These are both M. I could actually say M0, M1 here. And then I could Minkowski. Oh, I'm dummy. Minkowski vert. Yeah. Right. It's messed up. It was almost nice. Just about. Not real. Not real. Base. Yeah. You ain't gonna work like that. So we need M0, M1. Unlucky. Yeah. So it goes like this. M0, boom. And then M1, boom. Chilling. So then we grab M0, M1, mesh. Yeah, man. Vert edge face. Calm. Okay. Oh gob. Um. Self. Vert. What? Did I just do that wrong? Oh, I see. Self. Edge. Self. Base. Is this mesh? Do I really need these more trait? I do not know. Can you be doing like that? Jeez Louise. What am I doing here? 2 months ago. Oh my god. Alright, you can hold. Self. Yeah, I guess. So M0 and M1 have to do that? Isn't that just the same as saying you can't do anything? Lol. Um. Yeah. Not super happy with that, I must say. I was hoping for a little bit more Minkowski. Gah. Yeah, so mesh query is where I take the L. So if you have a Minkowski of a Minkowski, you just can't. It don't work. Yeah. No. Right. Good comments. Yeah. So I wonder if this just goes in mesh topology. Let's try that. Yeah, it's simple. Simplifies things. If you have topology, you have a face edge vertex. So that should be minus lines. Not as much as I'd hope, but okay. What am I doing that TXT? It's just gonna be hard. I'm lost. Lost in the sauce. The game engine sauce. The hell? Alright, well, my time is up. Well, I'm just gonna like keep going until I get the signal. Shh. Did I save any of this? So smooth. It's like the camera's glued to my mouse. Feels so good. I got like OLED response times plus 2000 FPS. Uh-oh. Fast. Ah! Damn. Fast is fun. That was a goofy route. Oh dear. I don't. Whee! Two. We hit the spawn because I'm afraid. I'm afraid I may not make it. Do, 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 do. Alright, I'm gonna miss this. Uh-oh. Ooh. I'm so addicted to this playlist. I don't trust that. All right, made it. Do, 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 do. Don't even think about it. Okay, up we go. You can do these two at a time, but I don't believe. Ooh, good key presses. Ah! Nice. Don't believe. I do not believe. I do not believe. Do not believe. Yay! Okay. Nice. Cool run. Now it's a functional game. Well, the thing is, like, I was at this point 2 years ago, and I've just been like I was like, and then I just been like looking blindly for a way forward for 2 years, but not continuously. I had to stop developing the game because I ran out of money, and that really killed everything, really. And I'm trying to get back into it, and I've done a big replacement of a core algorithm of the physics in December and January. And I'm still feeling the like earthquake from doing that. It's a massive change. Notably, let's go over here. Oh, notably, this part right here is one of the remaining death zones where it it breaks. And I basically hopped on it at a weird angle, going like this, always going to the left. That didn't even work, but oh yeah. So this is another bug where you can infinite loop, and these the objects in this map are problem children because the orientation is like it's like slightly off, which is like worst case for the physics, but it needs to work in every case. So debug, 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 debug. Oh, cha cha cha. I really want to rewrite the physics with an idea I had where I use like recursion rather than an intermediate allocation to um, loop over edges for each vert edge, loop over faces, and the other parts of the mesh query trait. I think that would be like another 2x speed up of the physics because intermediate allocations in the middle of physics is just a speed killer. I might also be able to write it more efficiently. It's kind of a waste of time because like it's already I'm trying to make it better and this is like a refactor. But that's what I'm here for. I'm here to work on it, not to finish it, which is a weird goal. But like if I wanted to make a game, I would be using a pre-built game engine. I want to make a game engine and then end up with a game. Work, work, work forever. Thrash the code. Crash the code. R. Hmm. Three minutes. Is that better? I suspect it's not better than my time. Let's go 5 men. What's it called? ISO. Hello? That took a long time. I should be in the top. Or not. Top N. Oof. Did I just not have a time? Tiny people playing B-Hop. Can I save the GPU if I play like this? If I go full screen, it like dies. Map. ISO. I don't have a time. Oh. 3 minutes would be right here. Oh, the frame rate is bad. Well, worse than... I don't believe. No. What is the frame rate? 300. Horrible. I can't see. Oh yeah, now OBS is dying. Great. Great. I kind of want to just like play off stream. I did identify a bug. I furthered the progress on this, and I fixed a separate issue. Why don't I work on like no clip? Tuesday, no clip. Because like that's, as I fix the physics bugs, I can rely on them less and less to like clip through walls and stuff. All right, I'm gonna go and play my game, and then go make $1 billion. Yeah, I'll see you tomorrow. Bye.